This is the ROS Developers Podcast, episode 97.
The ROS Developers Podcast, the ROS Developers. The ROS Developers Podcast, the ROS Developers.
Hello, ROS developers, and welcome to the ROS Developers Podcast, the podcast that gives you insights from the experts about how to program your robots with ROS. This is Ricardo from The Construct, and today I would like to dedicate this episode to all the people that are starting to debug ROS programs. So maybe you have started learning how to program robots with ROS. For example, taking the amazing courses that we do at The Construct, maybe. But the real proficiency in ROS you can get that proficiency by debugging your ROS programs. So you need to go into your robots, try your programs, they will not work, and then you have to find where the error is. That's called the debugging. And it's there where you are going to learn the most about ROS. Really, all the examples that we can prepare are the tutorials, are the courses, are the classes. That's okay, you need that base, but it's when you are confronting your errors in the programs when you are going to learn a lot about ROS and how it works. So if that is your case, if you are starting to debug ROS programs, this episode is dedicated to you. Very cool. Today we are going to talk about a tool that helps us to debug ROS programs in a visual way and in a faster way. But before going into that, let me tell you about the next online workshop that we are preparing at The Construct. It's called the ROS2 Industrial Ready Workshop. It is 1 week, 5 days workshop, 6 hours per day, where you are going to learn all the basics of ROS2 and then how to apply this for making robots navigate and how to make robots manipulate, grasp objects, and all the things related into an industrial environment like this one that you can see here in the background. Even if the workshop is online, you are going to be practicing with the robots that you can see here. For example, the mobile base from Robotics, or the UR robot, armed robot, doing grasping and doing navigation around, all this using ROS2. So if you are interested, I will put a link here below on the comment section, well, on the description section, and then you can enroll. This is the last week to do that, okay? Great, so now, let's go to the meat of this episode. Let me introduce you, Adrian Macneil, who was a former director of infrastructure at Cruise company. And now currently he is the CEO and co-founder of Foxglove. And that's a company that is in the mission to create better robotics visualization tools. And today we are going to talk with him about the tools that they are developing to simplify the debugging of ROS programs. Welcome to the podcast, Adrian.
Hi, Ricardo. Nice to meet you. Nice to be here.
My pleasure, my pleasure. It's been some weeks that we've been after this interview, and finally we agreed on the day and time.
Yeah. Glad we could get it sorted.
Yes, great. Where are you located now?
I'm in the Bay Area in San Francisco.
Okay, great. And you have founded this company, which is Foxglove, and which is the precursor of WebRTC, which was a visualization tool made at Cruise.
Yeah, exactly.
What was about this, and were you involved in the process of that tool?
Yeah, exactly. So I, before founding Foxglove this year, I spent the past 5 years at Cruise in San Francisco. For those not familiar, Cruise is a self-driving car company. They are have investors from General Motors to Honda to SoftBank to Microsoft and Walmart now as well. So they have a lot of funding and definitely one of the leading contenders in the self-driving car space. So I spent a long time. I joined Cruise when it was a very small company. It was about 30 or 40 people, and saw that growth of what it takes to take a small robotics development team and scale that up into 1,000+ people. And so my role there was leading all of the infrastructure and backend developer tools. So we spent a lot of time looking at how we manage data coming off the robots. We spent a lot of time looking at how we do our CI and testing and simulation, running simulations at scale, and a lot of time looking at how the roboticists at Cruise debugged the robots, how they understand what is the car doing, what is the car seeing, what is the car thinking. And that was really the genesis for WebViz and later Foxglove. So WebViz was a tool that came out of Cruise. We started developing it about 4 or 5 years ago. At Cruise, we really noticed that our engineers at Cruise were struggling with the kind of out-of-the-box ROS tooling. So some of the tools that you might be familiar with, such as RViz and RQT and things, we noticed several points. One is that there's just a lot of tools. There are a lot of tools there to learn, and if you know how those tools work, it's great, but it's a lot of stuff for us onboarding a new engineer at Cruise. It's a lot of stuff that we need to teach them. It's a lot of different tools that they need to open and get used to. And we also noticed that those tools were not cross-platform. So typically, and again, this was back in the ROS 1 days, some improvement has been made there with ROS 2, but it's still really difficult even today to run RViz on Mac, for example. Yeah. That's just, you know, I think that's something that you can do with the construct even. You can run this sort of in a browser, but yeah, it's something that we noticed was just really difficult for engineers to debug across platforms and to get access to that data. And we wanted to make it really easy for engineers to just be able to receive an incident or an event. So an event might be, you know, the car accelerated too quickly or braked too quickly, or there's some kind of note that's been made by one of the safety drivers that says, hey, this is something that we should look into. And we want to make it as easy as possible for you to look into that event. So you ideally, in a perfect world, you would just click on a link and then it immediately pops up in your browser, just like Netflix, right? You click on it and then it pops up and you can immediately start debugging your robots. But what we noticed with the traditional tools was that wasn't the workflow at all. They had to kind of click on a link and maybe download a large bag file. So you might have a 10 or 50 or 100 gigabyte bag file that you're trying to download. And so you have to wait for that to download to your computer, and then you need to check out the code base, and you need to get the right version of the code base because maybe this happened last week, and you know, things have changed since then. So you need to check out the version of the code base, and then you need to build the code base, and then you need to open RViz, and you need to open RQT, and you need to open all of these other apps. And so there's just a very long cycle from when can I sort of get assigned this project to work on versus when am I actually like working on the issue. There's a lot of just setup involved there. And so we really wanted to make it more accessible to people, make it one visualization tool that would allow you to inspect any kind of part of the robot. And we wanted to tie this in with our data storage as well, so that we could easily just click on a link and immediately start looking at it and not need to actually download files locally. So that was another big part of it. And even when you do have local files, like I mentioned with RViz and RQT and some of these tools, you typically still need to have ROS installed locally. You need to have a working development environment, and that's not very scalable if you have large development teams. Quite often, if you have someone, you know, a QA engineer, a quality assurance engineer, or a data scientist or something who maybe is not super familiar with ROS development, or even sometimes a TPM, like a technical program manager or a product manager, or people who are not coding day to day, but they still want to be able to click on something and look at what the car was doing and understand that without needing to have a whole ROS kind of development set up. So yeah, so we set out to solve those problems. We also decided to build this on top of a web stack. So This means RQT and RViz and a lot of the existing ROS tools are built in C++, and that makes it difficult to run cross-platform. They use the Qt development environment. It's theoretically possible to build cross-platform apps, but you know, as we've seen with ROS2, even as recently as sort of the last year or so, they've kind of originally committed to supporting Mac OS and ROS2, and then I think they sort of decided in the latest release that wasn't something that anyone really had the time to support. So even though these things are theoretically possible, they're not easy. So
they are not.
Yeah. So we set out with the web stack. We decided that building a browser-based tool was the best way to do this. The web, you know, for those who maybe are not super familiar with web development, a lot of progress has been made in the last few years, even, but especially the last 5 years, about bringing more powerful applications to the web. So we have new technologies such as WebGL, which basically allows you to run GPU accelerated 3D environments inside your web browser. We also have WebAssembly, which allows you to compile actual C or C++ code down to a bytecode that runs in the browser's virtual machine, sort of in a similar way that Java works. So you can actually take native C++ code and we can compile that, and we do that in some cases where we have like very performance sensitive areas of the code. So you know, the web is becoming a very powerful platform. There's a lot of tools out there that have built things on that platform lately, and tools that are really pushing the boundary. So we thought that was the best path forward. It means that anyone can use the app inside their browser. It means that we can work it automatically across platforms. And it even means that we can allow people who just, like I say, they just have their Mac laptop or something, they can easily just click on a link and immediately start kind of drilling into data. And that doesn't mean that we think that, you know, I think robotics development is very heavily tied to Linux, and Linux is a very good platform for robotics software for the actual brains of your robot. But that doesn't necessarily mean that you should be forced to use Ubuntu or Linux as your development environment. Maybe you prefer a Mac development environment and you can write your code there and just connect to your robot remotely.
Yeah. Yes. Do you know about WebRTC?
Yeah. So that's another
cool.
Another very interesting technology that allows two computers to connect to each other. In fact, it's very often used when we're doing video conferencing and things like that too, where you need two computers that have kind of a direct connection. And that was a technology that we used at Cruise actually for our remote assistance. So this is when, if the car is ever unsure about a particular decision, it can make a call to a human operator, and the human operator can sort of approve or revise the plan for the car. So if the car comes up and it says, you know, I think the street is closed, but I can't quite tell why the street is blocked. And then the human operator can say, yeah, that street's closed, just go around it. Or they can say, no, that's fine. You just need to, maybe it's just construction or something. So we use the WebRTC there for having a live video feed from the car, which is really cool.
Yeah, we are using WebRTC in our academy. So
cool.
The people, they can connect remotely to our robots.
Yeah.
And then by using a joystick, we have it there. But they can connect a joystick to their computer, and then with that joystick, they can move the robot remotely, because WebRTC allows you to access the hardware that is connected to your computer that has the web page launched.
Yeah, that's really cool. Yeah, so it's really incredible what you can do with a browser these days. That's quite exciting.
I also agree in what you mentioned about I think that the web is going to be the interface of the future for robots, specifically for what you mentioned, which is a universal interface. I imagine that all the service robots that we'll have around, when they are more popular, they will be running a web server, and then anybody with the phone, they can just connect and check what is happening anytime. So you don't need to have any special machine. Definitely. We pay a special attention in our academy to teach the ROS developers some lessons about the programming on web interfaces.
Right. And often it is different skill sets, and we notice this at Cruise as well, that quite often the web developers and the front end developers who understand the 3D, the browser technologies. It's very different from the roboticists who maybe are really good at C++ or Python or understand, you know, the actual algorithms and the machine learning that's happening on the robot. But we can bring this together and we can bridge that gap. And yeah, that's something that I'm really passionate about.
Great. So great. Then let me see. So you were involved in this development of web-based at Cruise. And
yeah. So
point in time, what happened?
yeah. And so I like I said, I oversaw all of the developer tools and infrastructure at Cruise. So several of the people that were on my team were working on WebViz and you know, came up with this project. Around maybe 2 years ago in 2019, we open sourced WebViz. So that was an effort just to try and give back to the community and say, hey, we built this thing, we think it would be generally usable. Unfortunately, a lot of the WebViz code was specific to Cruise. There's a lot of, you know, visualizations, and also sometimes
I tried. It was quite difficult.
Yeah. So it was a really powerful project, but it was never designed from the ground up to be a general purpose robotics tool. It was designed for an internal tool for Cruise. We published the code to give back to the community, but we at Cruise did not have the sort of resources to build a community around that, or to build features that were not useful to Cruise. And so there was a lot of, I guess, there was a combination of the fact that a lot of the WebViz code was still not open source. There's a lot of features that only exist internally, and the fact that that a lot of the features that people started asking for, even now, if you look on the WebViz GitHub, people are asking for ROS2 support. People are asking for extension APIs. People are asking for, you know, better panel management, better layout management, and things. But just Cruise, I mean, this is not in any way meant to reflect negatively on Cruise, I think, but Cruise is for good reason, is focusing on building a self-driving car, and building a community tool is kind of, you know, a little bit of a distraction from that. So most of we're on very good teams with the team at Cruise, but they continue to focus on what's important for them, which is building a self-driving car. But yeah, we really felt that there was an opportunity to sort of bring this out to the wider industry. We felt that this was the beginnings of a very exciting tool, but that we felt that it needed to sort of be decoupled from Cruise and made into a separate project and a separate company. So that ultimately led to founding Foxglove this year. We're a small team. We have 7 people at the company. Many of the people at Foxglove have worked on WebViz in the past, so we have a lot of knowledge about, you know, what went into WebViz and why some decisions were made. But we also have a lot of our own thoughts about direction we would like to take it, and new features that we want to add, and how we can sort of break it free from not just serving self-driving car companies, not just serving internal needs, but making it more useful for the entire robotics community. And that's what we're starting to see now. We're starting to see a lot of other different types of robotics companies using it.
Okay, great. So now I can see the difference. I was very interested to know the story from your point, because I tried the WebRTC, and actually we even created a video showing the features of WebRTC. It's published in our channel, and we published at the ROS Dev Day in 2019. So it was shown to the people. 19 or 19.
Well, we can update that now to use Foxglove.
To what? Sorry.
We can update the tutorial now to use Foxglove.
Okay. Yes.
Yeah.
Okay. That's on the checklist, because I have seen your application and it's super cool. Really. It's very nice.
Awesome. Thank you.
It's very nice. It's very nice. Let me see here to the questions. So you explain about the WebViz and so on. Then your main tool for visualization, it's called the Foxglove Studio, because the company is called Foxglove.
Yeah, exactly. So Foxglove Studio is just the application. So this is something that you can either run in your web browser directly, or you can download on your computer and run and we have native downloads that run on Mac, Windows, and Linux. So you can just download and install that like a normal desktop application. And it runs natively just like you would with any other app on your computer, which is nice.
And why do you have the two versions?
Yeah, so that's a good question. I guess, so there's a few things. I was talking about, the browser being a very powerful environment, and we can build a lot of, we can build a lot of things in the browser, but there are still some things today that are not possible in a web browser. And so web technologies such as, React and JavaScript and TypeScript and WebGL are all great technologies, but there's some things that the browser limits you from doing. So you cannot open a native TCP connection or a native UDP connection. You can open WebSockets and you can open HTTP connections, but you cannot just start sending UDP packets around from the browser. It doesn't let you do that. So there are now available these technologies that let you take a web application that you've built, bundle it up inside a native application so that you have the web application that looks and feels like a native app, but then you can also run native code alongside that. So we can run any C++ code that we want, or we can make native connections to, like I say, to TCP and WebSockets. So I think there's two reasons. The browser version has almost all of the features. I think there's two reasons that you might decide to download the web app, to download the desktop app. One of those is if you just prefer a desktop app. Sometimes it's just easier to find if you have it on your computer and you can click the button and it pops up and you don't have to go looking for a website or a bookmark or something, especially if you have multiple windows floating around. So that's one reason. And then the other reason is that there's some features that we can do directly in the native application. So that is, maybe I should back up a bit. In WebViz, you can connect to, there's two things you can do. You can load a bag file, which is a recording of historical robotics data, or you can connect to a live robot. But if you want to connect to a live robot, originally you needed to use the ROS bridge protocol. So that means that you need to take the ROS bridge node, which is an open source ROS node, and you need to run that on your robot. And that ROS bridge node opens up a WebSocket server on your robot. And then that is accessible to be connected to from the browser version of Foxglove Studio. So that's nice, and it's not super difficult to set up. You just have to run the ROS bridge node, you have to install it, you have to open it. But maybe if you're just developing a brand new project, you don't want to go to all of that extra work. So it's nice, especially if you're used to AVAs or RQT or some of these tools, you just want to connect to the actual robot that's just running, or the software that's just running directly on your computer or directly on your network. So we can do that. We have what we call a ROS native connection. And so this works with ROS1 and ROS2. You can just connect directly to a running ROS instance, which in ROS1 you connect to the ROS master. In ROS2 there's no ROS master, but you just type in the connection and it finds it. So so you can do those in the desktop version of the app, but both options are available. If you prefer the WebSocket, there's trade-offs to both, I guess. The ROS native connection is a little bit easier to get up and running, but the ROS bridge, the WebSocket protocol, is nice sometimes if you have a network where there's maybe a firewall involved or something, and you only have one port that you want to expose and everything's going to go over the WebSocket protocol. Sometimes that's easier for people. So we provide both options.
Okay, now it makes sense because you were promoting all the benefits of working with web technologies, but then, okay, but we have here a native application in Mac for Windows or Linux.
And sometimes people just have the preference, right? Yeah,
Sorry?
sometimes people just have the preference. Sometimes people just want to download the application and just have it running as a dedicated app on their computer. It's a little bit nicer. And we can still make that a really great experience.
Actually, do you have any statistics about which one is most downloaded?
Yeah,
or used?
So I think it's about 2/3 right now. So when we first started, actually, at the beginning of the year, we actually pushed a lot harder on just using the desktop app, because the desktop app has the advantage that we don't have to worry about cross-browser support as much. We don't have to worry about people running old versions of browsers, or even today, actually, there's some features that we cannot support in Firefox and Safari because we're using very new browser technologies, and sometimes they haven't always come available in every browser. So that cross-browser support is something that we're working on. But when we first started Foxglove, we thought, well, let's just put that aside and focus on the desktop app. So we were really making the desktop app kind of the main experience. People can download it and use it. But we did get some feedback from people from the community that they really like having the web version available. That sometimes there's, like I said, at a cruise, sometimes you just want someone to be able to not install anything. You just want them to be able to, click on a link and go to a website and start looking at some data. So we sort of resurrected the browser version and started making that more publicly available and linking to it from our website and things, more than just a proof of concept, actually just making it properly like a first-class supported feature. And so that only has been maybe in the last couple of months that we've really started linking more actively to the browser version. But I would say that I think the last time I checked, maybe about a third of people were using the web version and 2/3 of people were using the desktop version. So, yeah, there's actually still more preference for the desktop version.
Yeah, I think based in my experience that people are going to like more the install version.
Right.
We still have this necessity to have the programs installed in our computer. It's like in the previous to Netflix, I want to have my disk of the movie or downloaded the file on my computer.
Yeah, definitely.
But still not used to that. So I expect that this is going to be, the native application is going to be a success.
Yeah. It's nice. It's nice having a desktop app, you can feel it. There's plenty of things that you can do in the browser these days, even Zoom and things like this. You can run them in the browser if you want, but it's just nicer having a desktop app, I think.
Well, in my personal opinion, okay, so I try to do everything on the web so I can forget about installing, and then when I change computers and so on, everything is running. But I know from our students that they prefer to have it installed. They are always asking, how can we install this? How can we install that? They are always asking to install the files that we provide them and so on. So,
yeah.
And in terms of development for you as a company, is it a little bit difficult for you to manage so many different versions?
Not particularly. We have a lot of just automation built up. So our CI runs. So every time we submit code, if anyone in the community submits a pull request, we build the desktop version and the browser version, and we run a lot of tests to make sure that they all work correctly. And then our release process is also very automated. So we just have to tag a new version, and then it goes and it automatically builds applications for the Windows, Mac, and Linux, and it pushes out the browser release, and it signs the builds for Mac, and then that automatically gets pushed out to our website now. So the latest version, it'll always link to the latest version on the website. So we just put a lot of automation in place so that it's not too much to manage. And then, I guess it does maybe introduce potential different bugs that you might find that only happen on some platforms. Like we found one bug that only happens on Windows if you have a non-English font selected, and it's only happens on Windows, and it only happens if you're not using English font, and it only happens if you have a high DPI, like a Retina screen. And so you get these sort of strange bugs that only happen on one platform. But like the same thing is true on the web, right? If you have people using Firefox and Safari and Chrome, like it's not magical. Like, if people are using different software, you're going to always run into sort of different bugs that you have to figure out they only happen on one platform.
Yeah, all right. Okay, I understand. Now, you mentioned that your application Foxglove Studio is working for ROS 1 and ROS 2 already, right? And any particular distributions, or how does it work?
No, we support ROS 2. We just recently fixed a few bugs in Foxy because we've mostly been focusing on using Galactic, which is the latest version of ROS 2. But just in the most recent version that came out this week, we fixed a couple of bugs that were happening in Foxy. Other than that, it's pretty much works out of the box with any ROS 1 and ROS 2 version. We do actually theoretically support non-ROS robotics frameworks as well. So the way that the connections are implemented in Foxglove, you can write a connection that can talk to any data source. And we have actually done some work here around, we have a connection that can talk directly to a Velodyne LiDAR, for example. And you can just plug the LiDAR into your network and talk directly to it. And as long as there's a connection in Foxglove Studio, it can just communicate with whatever remote robot you're running, even if you don't use ROS and you've just built your own system. We can, in theory, you can write a connection for that in Foxglove. And then all of the visualization panels are perfectly happy to just receive, as long as you can kind of, pass the data over to the visualization panels. They're perfectly happy to work with that. So yeah, that part's nice. There's a few features that we, that are maybe slightly different. Like in ROS2, we are, when you load a bag file in ROS2, there's a bit of a regression that happened from ROS1 to ROS2, where the ROS1 bag files include all of the message definitions. So they include all of the definitions that you might have written. And so there's a lot of standard ROS message definitions like point cloud 2 and image and things like that, and marker that you're familiar with. But then a lot of ROS developers will create their own messages, and they use those for passing around. And obviously you want to look at those when you're debugging. And in ROS1, all of your custom messages were saved into the bag file, which means that we could open a bag file, and even if we had never seen your code base, we can just start like looking at all of the content. In ROS2, as of right now, the bag file does not include any custom messages, which means that when you load a ROS2 bag file into Foxglove Studio today, we can only show the standard ROS message definitions. And so this is just something that we're working on. It is possible to work around this by running ROS locally and connecting to it over a ROS bridge and playing back the bag, but it's a little bit more clunky than we want it to be. So we're actually working really closely with the ROS2, with the ROS tooling working group, which are responsible for the ROS bag 2 format. And we're hoping that in the next coming release of ROS, which I think will be Humble, that's coming next year, then we'll have this problem solved and we'll have the actual message definitions in the bag file, which means that you'll just be able to drag it in like you can with ROS1. You'll just be able to drag it in and start looking at your custom messages. But yeah, other than that, all of the ROS versions are supported. So if give it a try, and if anyone has a problem, we're happy to take a look. Just file a GitHub ticket or join our Slack, and we're happy to have a look if anyone has a problem with a particular version of ROS.
Okay, great. Then let me see. Oh yeah, I wanted to ask you. So you have been talking about the ROS bags and visualizing the data inside of the ROS bag. Does that mean that Foxglove Studio only works with ROS bags, or can it also work with real-time data being generated right now on the robot, so you can visualize that?
Yeah, no, exactly. So we can do both. You can connect to a live running robot, or you can load ROS bags, and that's something that we think is really important. A lot of the times in early robotics development, you don't even bother with recording ROS bags. Quite often, you just have your robot and you're just debugging it. You just connect to it live and you write some code and see what happens. And that's that's a really powerful workflow that's important. And that's with RViz and RQT and some of the kind of original ROS tools, that's really the only way they work. They only work with a live ROS connection. And if you want to replay, if you want to open a bag file, you need to actually still open a live ROS connection and then just play the bag file back to it, which is like, again, a little bit clunky. So we wanted to add this new feature where you can just drag in a bag file and view it straight away without having to have ROS running in the background. But we can definitely still support the method of connecting to a live robot.
Okay, great. That's very, very important. I think that is the main usage. And what can you tell me about the difference between Foxglove and RBase or other tools like RQT console that are the original ones created for the ROS developers? Yeah,
exactly. So so we have, I guess, first and foremost, we sort of felt that a lot of the ROS tooling ecosystem was quite fragmented. You have RViz, and then you have the RQT tools, and you have RQT Graph and RQT Plot, and a lot of these different tools. And we found that developers often have to open up several different applications and have all of these windows kind of arranged on their desktop how they like them, but it's quite hard to get that state back. So if you've set all of these windows up, you've set up others here and you've set up RQT over here, it's that maybe that's how you like debugging, but then it's really, if you go away and you close down your computer and you come back tomorrow, now you've got to go and set it all up again. You've got to open all these different windows and things. So that was a large part of what we wanted to do with Foxglove is we want to integrate all of these different tools into one application. We have basically a tiling panel system where you can set up a layout, and you can set up your 3D window here and your image window here and your some raw messages or some plot panel or anything that you want. You can kind of set these up and arrange them how you like. And so we have equivalents for almost all of the RViz and RQT tools right now. There's a few things that we don't support, and there's some of those you see as sort of feature requests on our GitHub. We always appreciate people giving us a try, and if you say, hey, there's one particular tool or one particular feature that I'm missing, search in our GitHub and let us know, either upvote an existing issue or add a comment, or if you can't find any mention of it, then please let us know, create a new feature, because I don't think any one person in the world knows every single feature of every single ROS tool. So we're not going to, unless people show up and tell us that they want features, we can't add them. But there are, for most of the things that you can do, you can open up the 3D panel just like you can RViz. You can visualize point clouds. You can have markers. You can visualize transforms, the TFs. You can have we have basic support for loading URDF models. That is one thing that we are working on improving right now, is adding better support for loading a URDF model, so you can have an actual model of the robot in 3D space. And then we have plots, and we have graphs, and we have images, and we have some things too that you can't do with the existing ROS tools. So we have like a very nice topic graph panel, which will show you the connections between all the topics. And there's a lot of cool features to be able to sort of filter in and out different topics or different nodes that you're interested in. We have what we call the raw messages panel, which allows you to, it's basically like running ROS topic echo in your console, in your command line. So you can actually just run that directly in the app and have that window, which is really nice. And we also have a map panel, for example. The map panel will show you, you can just plot like GPS messages and things like that. If you have again, all these tools are useful for different use cases, but sometimes if you have a robot that either is a self-driving car running on roads, or an agriculture robot that's running out in large fields or things, then quite often it's helpful to be able to just plot that on a map, plot the entire kind of path that it took. So yeah, we have all of these. We have support for ROS diagnostics, which is a really interesting feature where you can set up the health of your robot, and you can immediately just at a glance see whether all of the subsystems are healthy.
How does it work?
So the ROS diagnostic system is used on some robots where you can publish a set of different diagnostics, and then whether they are, I think you can choose between okay, warning, or healthy. So for each, you might say my camera 1, camera 2, camera 3, and they can say okay, and then it might say my LiDAR, and it's like unhealthy, or it might say my battery level unhealthy. And so you can publish these through the ROS diagnostic system, and we have native support for that, for displaying that as a panel as well. So all of these different things are what we call panels, and the panels you can just drag and rearrange them exactly to make the layout that you find helpful for your workflow. And then you can always kind of come back to that layout every time you open the app. It's there, and we actually have support for creating multiple layouts, so you can have a layout that you use for a different workflow, and maybe some layouts that are useful for debugging some types of things, and some layouts that are useful for debugging other things. And then we also just recently announced our new upcoming team features, where we can actually have layouts that are shared among members of your team, so you can log in and have a layout for your team, which is really nice.
I was going to ask you about this, because you have released this very, very recently.
Just a couple of days ago. Yeah, just this week. Yes, exactly. So yeah, so that's really exciting. So we, and this maybe gets into a little bit of the topic around where we're going with open source and things as well. But so at Foxglove, we believe very strongly in the power of open source. I think especially developer tools, it's really important for developer tools to be open source because we want people to be able to customize them and extend them. And we want all of the features to be available in open source. So if you download an app, there's no kind of hidden features or anything like that. Everything's available. It's all there for you. But on the flip side, obviously, you know, people need to like pay salaries and things like that. So we want to have some idea of how we actually can produce money as a company and support ourselves and not just get by on donations. So we have the team features is something that we just announced this week. And so this is something where, like I said, if you're using Foxglove Studio on your computer by yourself, you get all of the features. There's no limitations there. If you want to use our cloud services, so basically you can log in, you can create an account on Foxglove Studio. Again, completely optional. If you don't want to, you don't have to, but you can create an account on Foxglove Studio, and we'll sync your layouts to the cloud, which is really nice because, again, a lot of people that we talk to are working across different computers. Maybe they have a Windows machine that's a desktop for developing some embedded software, and then they have their Mac laptop that they like because it's nice and portable, and then they have their Linux machine that they use on the robot itself or things like that. And sometimes people are debugging. Sometimes they're using all of these different environments. So we can now sync your layouts and your views and things across all of these computers, which is nice. And then we also have the ability to create a team, basically create an organization, and you can save this layout even for your whole organization. So as you get bigger, if you have a larger robotics team, you might have perception engineers or planning engineers or QA engineers, and they care about different things. They might care about how am I debugging a perception issue. It might be very different from how I debugging a planning or controls issue. And so you can create these team layouts and use that as kind of a template for your own personal work, so that the team can kind of benefit from collaboration, benefit from everybody's knowledge.
Okay, and that's one of the ways that your company is planning to generate some profit from the development of this work.
Yeah, exactly. I mean, it's still right now it's free for small teams, so we're planning to introduce some the sort of paid tiers when you have maybe more than 5 people on your team. But if you're a solo developer or you're academic or you're a small developer team, it's still all free right now. It's just the early days, but that is a feature that down the road we plan to charge for larger teams that want to. If you have 20 or 50 or 100 developers all working on the same robot code base, then that's something where we think those companies really can afford to support us as well.
Yeah, definitely. But one question related to that, and I think that the audience will be concerned, it's about the privacy. So when using this kind of accounts, is Foxglove recording any kind of data?
Yeah, so I guess there's 2 things, and we put a lot of work into our privacy policy, so it's available. You can go online and read, and we're very clear about what we do and don't collect. In Foxglove, even if you're using the open source version, there's 2 things that are options for you in the settings. So one is that we keep some very high-level telemetry data, such as just when you're opening the app and which version of the app you're running and things, so that we can get a sense of how many people are using the app. Again, you can go and disable that if you don't like. And then we also keep crash reports. So if the application itself crashes or has an unexpected error, those get sent to us so that we can make the program better for everyone. Again, you can disable those in the settings if you want. And then in terms of if you're creating an account and syncing your layouts to the server, some data does get sent alongside that. So basically, which panels are you using and which topics are selected in the panels. So the most information that we would see is maybe the names of some topics. I mean, again, this is all sort of not stored in a format that we're just browsing around looking for the names of topics, but if you have a panel open and you have several topics selected and that's part of your layout, then that is going to be synced to our cloud server. And so all of the kind of metadata like that, like which panels and topics and things are synced to the server. None of your actual robot data gets sent to the server. That's as part of the team's features, as part of layouts. None of your robot data is being sent. Yeah,
Okay.
there is a future. We do have some future thoughts around how we can make robotics data, the actual raw data, more accessible to people and make that easier for people to share among teams. So that's kind of a direction that we're looking at as maybe a potential future feature. But right now we never sync any robot data. It's always just the layouts and the views and things.
Okay. Yeah, I see that. More data, like for better improvement from your side than from
exactly.
recording data and having, this data generator.
Yeah, that would break your internet connection. I think if we tried to record, if we tried to send any actual robot data, it would would use up an internet connection very fast.
Yeah, no, but I mean, for example, localization of robots in a map, that's small things. Or, like, I don't know, about new commands being sent with every frequency. I don't know, data that could be interested in the future for sales or for other companies to make use of this, because this is a legitimate business model. I mean, if you mention this, then I mean, it's possible. I don't know. So I just wanted to know if your business model went into that direction or is not.
I think
it's not.
I think it's a good question, and it's a very valid concern. I think data privacy is really important, and I think one of the things that comes from data privacy is this concept of, are you paying for a product or are you the product? And this is something that you kind of notice with social networks, right? If you're not paying for it, someone else is paying for it, the advertisers are paying for it, then that means that you're the product. But that's not our business model at all. This is something that if you're using our cloud services, like I say, we might make it free for very small solo developers and very small teams, but it's something that we would expect as a company. If you want to use that and you've got a larger number of developers, then you're paying us for that service, and we would treat your data in that case as absolutely private. There's no way that we would be on selling that data, because that would be you're doing a disservice to the people that are actually paying us money. So I think you're totally right. It's very important to think about, is a company working for you or are you working for them? And in this case, we see this as a service that we're providing and people are paying for.
Okay. And what about if I do a product for a customer and then I install in that product your software? Do I have to pay any kind of royalties to you?
No. So that's kind of the beauty of open source, I guess. I mentioned at the start, but I think extensibility is really important with developer tools like this and with open source. And so this was one of the things, again, that we felt was lacking in WebViz, was the ability to create custom extensions and to be able to build your own kind of panels and data connections and things. So we have created a whole extension API, which means that you can come in and you can create, you can build a panel just with HTML and JavaScript or any web technologies that you like. And then you can make that available either to your internal developers or to a customer maybe, or to the general public if you want. And then you can use this, again, it's open source, so people use it in different ways. There's definitely people that using Foxglove as more of a dashboard type tool and maybe deploying it in an environment that is either facing their customer or facing like an operator, a robot operator, a technical operator. And that's really interesting. So that's something that you're welcome to do, as long as it's within the terms of our open source license. So the open source license says that the code is out there. It does say that if you take any of our existing code and you modify some of that code, there are sometimes restrictions around needing to keep the modifications open source. If you build your own extension, then that's totally fine. That's yours. So you can't take our kind of whole application and turn that into a closed source product. But you're more than welcome to use it with in a customer environment facing a customer. That's well within the scope of the license.
Okay, clear. Let me see, because we have been going through the questions in a different order, but let me check if we have missed any of the questions that I have prepared. Then, okay. So you mentioned about typical use cases already, and the visualizations types also. And oh yeah, can you tell us about some visualizations that are yet not available? Oh, you mentioned already about the URDF.
Yeah. So and in terms of maybe also just talking about like the types of robotics companies that we see using Foxglove, because obviously we started from more of a self-driving background, but we are seeing a lot of different companies now that are springing up that are, some companies are doing agriculture that have weed spraying robots and like farming robots and tractors and self-driving tractors and things like that are really interesting. And we have some companies that are doing underwater robots that are really interesting. We have some companies that are doing sort of like factory and logistics operations, like self-driving forklifts and things like that. And we have some companies that are doing more sort of, a lot of these are like industrial use cases. We have some that are doing like food preparation and things like that. So yeah, there's a lot of different use cases. And when we talk to these people, sometimes there's different things that they want. And something that really came out, you notice a lot of the self-driving car and self-driving tractor and things like that, companies are not as concerned about loading the robot model into the workspace. Sometimes the robot model for a self-driving car, the model is usually just very static.
Just a cube.
Right, it's just, you want to know the size of it, but you don't really care about having different joint states and things like that. But we notice for teams doing manipulation, so like if they're using a UR arm like you've got behind you, I can see, those often you care a lot more about having an actual interactive version of the model of the robot. And so that was something that that we've had a lot of feedback on and that we're working on at the moment, is having better support for actually loading a custom URDF into the visualization. So that's interesting. Other visualizations that we are thinking about, we have support for rendering your transform tree in 3D space, so we can show you your transforms and how they relate to each other and the different joints on your robot. But something that was suggested to us the other day was having actually more of a transform graph panel. So I think this is something that RQT supports, where you can just show sort of a tree view of, this is my root transform and this is the different transforms that are hanging off it. So you can get a kind of a visual understanding of your actual transform structure. So that's something that we're thinking about now, that was just recently suggested. But yeah, other than that, we have a lot of types. There's sort of probably 20 existing visualization types that you can work with.
And people can do their own by using the API for extensions that you mentioned.
Yeah, exactly. So you can use the extension API and you can build your own. And with the extension API, we have, so when you build an extension, you write that in using web technology. So you write that in HTML and JavaScript or anything you want. You can optionally, if you want to use React or TypeScript or these things like we do, you can do that, but it's not a requirement. You can write a very basic panel that just has a couple buttons on it and publishes a message maybe. You can do that. And so we have the extension API. We have an extension kind of registry so that you can go into the app and click on it and view extensions that people have published. Right now, it's very early days. So the only extensions we have that are publicly available are ones that we've kind of built as demonstrations. So we have an extension called the Total Sim extension, which allows you to, I don't know if you're familiar with the Total Sim, which is kind of the very first ROS getting started tutorial that you do. It has you sort of load this little app where you see a turtle kind of swimming around in the ocean, and you can control it. And so that's something that we sort of recreated as a Foxglove extension, so that you can view your little turtle and have it swimming around in the ocean. And that's just kind of a demonstration of what you can do with extensions. All of the people that we talk to that join our community in Slack and GitHub and things that are building extensions right now are doing them sort of closed source for the internal company needs, which is sort of what we expect. I think a lot of people, by the time you're building an extension, if it's something that the whole community needs, then quite often that just ends up as a feature in Foxglove itself. And if you build an extension that is for your company, then usually it's not really you don't really want to share that because it's not relevant to other people. So most of the extensions that get developed are kind of private and closed source, but we do think over time, more people will build really cool extensions that we can make publicly available.
Yeah, I'm pretty sure you just started, so we can say that.
Right.
We just started, so
yeah,
so
yeah.
I'm
We only
pretty
launched
sure.
extensions a few months ago, so yeah, it's early days, but yeah.
Great. And one point, so the visualization tools, they are taking the information from the topics and then showing in some way. But what about publishing in topics? Is it that possible from the Foxglove studio?
Yeah, that's a really good question. So it is possible. We have support for two-way communication with the robot. So you can do this in a couple of ways. We have we have a publish panel, which is very basic. You can just configure it with a message that you want to send, and then you can kind of flip the panel around and it turns into a button, and then you just get one button and you push the button and it sends the message. So it's a little bit basic, but that's possible. We also have...
does it fill the message for you? And you only need to modify the values?
You have to decide what message you want to publish. So if it's one of your custom messages, you need to actually specify the values as well.
Yeah,
although that's actually a really good idea. Yeah, if you could just select the message type and then just fill in the values, that would be nice.
Well, I was thinking about, for example, when communicating with action servers or in manipulation, that the messages, they are very large and difficult. So
so we do prefill a little bit. So if you can kind of choose from a drop down an existing topic, and then you can choose the data type. And we do actually prefill kind of, it's not quite like a text box entry, but we do prefill the structure of the message for you, so you don't have to type out kind of every letter. But yeah, it's a little bit more of a demonstration. I think we're curious to see how people use this. So the other publish panel that we have is a teleop panel, and it's basically just 4 arrows. Again, it's not supposed to be very complicated. It's more of a demonstration, but it can publish a geometry message twist. And so you can have just arrow keys up, down, left, right, and you can decide how that maps to your robot. But maybe if you've got a little remote control robot, maybe it's forward, back, left, right. Maybe if you have an actual robot arm or a UR arm or something like that, then you can actually have, don't forget, you can always have multiple panels. So I can always just have like different panels, and each one can publish to a different joint command or something like that. So those are there. That's kind of demonstration publishing. I think one thing we do not support yet is calling services. So in ROS, we can publish a message, but we cannot yet call ROS services, which is something that we would like to add. I mean, again, all of these things, it's just a case of priority. So if people want these features, it's always really nice if you jump on our GitHub and add a comment or give a thumbs up to one of the existing issues. But yeah, we at some point we would like to add support for ROS services. And then
in my case, so in my experience, I never needed this tool for communicating with services, with calling the services. I mainly did it from the terminal, and that was okay.
Right.
Enough. But for action, that's interesting for actions. So I was using the AIX client application, but it's very rudimentary. It's very basic. It doesn't work very well. Yeah, exactly. So that's something that we could add better support for. I don't know.
And then we also, like I say, I think with building publishing support, there's only so far we can go with the drag and drop interface. And so that's something where we say, we have this example panel, we have the kind of teleop panel with the up, down, left, right buttons. People can copy that into their own extension, and they can create, if you have a more elaborate dashboard, you can think you have a sort of industrial robot and you have buttons for starting a task or ending a task or commanding their robot somehow. It'd be perfectly valid to build your own panel, and you can just use HTML to lay out any buttons that you want, and then each of these buttons could be hooked up to a different service or a different topic or things like that, or actions. So those are things where we see extensions being really great for, because you can build sort of an interface very quickly. You have most of your 80–90% of the interfaces already built for you, and then you can just build a sort of a custom panel to maybe have some controls on the side of that, and now you have a dashboard for your robot very quickly.
Great. Great.
Yeah.
Let me see here. Any other questions? Yeah, so you mentioned about how to create the developers, their own extensions. There was in JavaScript and other technologies, not in C++. And also to mention about the Foxglove for Teams. So let me check about the, yeah, so I think that we covered all the questions that I have here planned. Then I have a couple of questions more just to finish the interview. Yeah. And the first one is about the plans for the future of Foxglove. Can you tell us something?
Yeah, definitely. So we have, I would say, 2 tracks. One of the plans is just, there's a lot of, as we've talked about, there's a lot of existing feature requests we know about, and there's a lot of stuff. And we really want to keep going down this path of making Foxglove Studio the one kind of integrated development tool that you need. So we want to get to a place where you feel comfortable not needing to have others or RQT available, that you can work from your Mac or your Windows desktop, and you can just have everything you need to interact with the robot. Apart from, obviously, you need a code editor and you need SSH connection to your robot. But we think that this can be the one tool that gives you all of the visualizations, everything that you need to be able to see what was my robot seeing, what was my robot thinking, what was my robot deciding. And so we have a list of feature requests. I would say we have a lot of functionality already, and there's definitely many teams that we know of that just use Foxglove exclusively. But if there's anything that you feel is missing, we have a lot of development effort going into open source. We have a big community, or a community that's starting to grow. So we would love to have any pull requests or anyone who wants to contribute to the community. Even if you don't know web development and you want to contribute to the community, you can always sort of help out by answering questions for people or joining our Slack channel, or even just giving us feedback about which features you like. And yeah, feedback is really valuable. So that's a big focus for us. I would say that's our main focus, is just continuing to build the community and continuing to build this into a really great tool. Like I say, this is something that several other people on our team have been working on for years already, and we're just really getting started now and bringing it out to the community and making it what we think is the best tool for robotics developers. And then, yeah, the other thing that we're thinking about, again, is over time, we want to introduce more of these collaboration features for larger teams. So this is, again, just thinking about how we make money as a company, how we can offer services that fit alongside the visualization. So we talked a bit about synchronizing layouts and things like that. We have put some thought into allowing you to do things like add maybe comments or tags if you're reviewing historical data, and being able to actually make notes that other people in your company can see about that data. And then we're also looking at the space of how people are managing their bag files and their recorded data at scale. So again, I think when you're a very small developer and just one person, you don't really need to worry too much. You only have a few bag files lying around on your computer. It doesn't take up too much space. But as you get a larger robot with more sensors, more cameras, more LiDARs, things like this, the bag files start to get very heavy. It starts to take up a lot of space. And then also, as you get more and more developers, if you get 20 developers or 50 developers or 100 developers, it just becomes very difficult for everyone to know where this data is stored and where you're accessing it. And I keep coming back to how we want to just have this workflow where you can find a piece of data, maybe you can search for it, and then you can click on it, and then the link, you click on the link and it just immediately starts opening up in your browser. And if you have an event that maybe you have a 1 hour recording and 33 minutes in, there's some event that you care about, I don't want you to have to download that whole 1 hour file to your computer, right? We want to just be able to click on it, and it's kind of just like Netflix. So you can just click on it and it pops up and immediately start looking at it. And so that's something that we're very interested in. I think the data storage, kind of bag data storage solutions that are available today are not as powerful as they can be, shall we say. Most of the large companies that we talk to just build their own from scratch, which is a lot of work. That's not super valuable use of time for a robotics company to be spending time thinking about their sort of bag data storage. So that's another thing where we're thinking, I think there's an opportunity there to provide more of a service that is available, again, as sort of like a paid service, and it sits alongside the visualization. And that means that we can keep, like I say, we always want to keep the visualization tool as open source and free and have all of the features available. But if you want to use the hosted cloud services, then those are sort of something that you pay for.
Mm-hmm. Okay. I like it. One thing that you mentioned here, what you were describing about Foxglove, as you mentioned that it's a tool for visualizing the status of the robot. I don't know the exact word that you mentioned, but it's what the robot is thinking that it is doing and it's a state, right?
Right. And visualization, people, I think, coming from other industries don't understand why visualization is so critical for robotics development. Exactly. Because when you build a normal application, it's very sort of black and white how the application works. So you can step through your code and you can add a print statement, or you can put a breakpoint and you can stop and you can say, oh, well, variable X equals 12. And it's, it's just very clear. You can kind of have these things where you step through and maybe you fill out the form and you click submit, and then the next page should show you that like an account was created or something, but it's very deterministic. You kind of have like, I fill out the form and then I click the button and then the thing happens. And you can always put a print statement or a debugger breakpoint and pause it and just see, oh yeah, my name is correctly in this variable or whatever. But it's all sort of textual, and the data that you're representing is a lot more simple. And then you come over to robotics and you say, well, why did my robot fall down the stairs? Or why did my self-driving car get too close to that cyclist? And that's a very difficult question to answer. So you need to step through visually. Okay, first of all, like what do I see? Because as a human, I can look at these things. I can look at the sensors, I can look at the camera images. And if there's a huge pile of mud on the camera, I can immediately say, oh, there's a huge pile of mud on the camera. And I wouldn't be able to tell that if I just set a print statement and tried to print out like an image or something. And then I can say, well, okay, the cameras are working fine, but how did my perception system work? Did I detect all of the objects in this scene? Like, the bounding boxes are there. Can I see that I've like correctly detected and classified all of these objects in the scene? And often, again, it's very difficult to do that from a traditional debugger, but visually you can just immediately look at it and say, oh yeah, that bounding box is wrong. Or I can, with my localization, I can immediately look and say, oh, my localization is wrong, because I can just see that the map, the returns that I'm getting from my LiDAR or something are completely different to the map. And I can look at that and go, oh yeah, well, a human can just look at that and say, well, that piece fits there, and like, obviously it's wrong. And so it's as a human, we're naturally pre-wired to answer these types of questions, and you can look at it visually and understand it. And so I think of it as, how can I see what was the robot seeing? Like, oh, are my senses correct? And then what was the robot sort of perceiving and understanding? Did I actually understand that scene? And then what was the robot sort of thinking? Did it have any predictions or things like that? Again, it's pretty easy to look at a prediction visually and say, this person's walking in that direction. Or we can look at a person waving at us and say, oh, obviously they're not, or this person's on their phone maybe. So I can tell that they're not going to cross the intersection. And then, what decisions did the robot make? Like, how is it planning on moving through the scene, or moving its arm, or or driving around the scene? And so, it's visual debugging is just very important to the robotics space. And I think that's something that is not appreciated maybe fully if you come from other industries.
Yeah, because they are not used, because they are used to the typical debugging. And I think that this is one of the key points of the success of ROS, is because it provided this R-based tool that other frameworks that existed that were competing with ROS at the same time, they were not providing. I would like to share with you one case that it was when I was developing humanoid robots at another company, PAL Robotics, and we were using sonar sensors. And then we couldn't figure out why the robot was not being able to get into through the door. There was space enough, it was clear, the algorithm was working, but until we use a visualization tool, we could see that there was a ghost obstacle being produced by the reflections of the sonar in that particular. So it was putting an obstacle there and then planning around. And we couldn't see by watching numbers or doing prints. Because it's a stream of data. It's a stream of data.
And as a human, you can look at that and say, oh, that's not an obstacle. That's just a ghost.
Yeah, exactly.
Yeah. So that actually that reminds me of a story from Cruise. And I think a lot of self-driving car companies have this problem. But in San Francisco, there's the subway system and things like this. And in the winter, a lot of steam comes out from the ground, from the subway and from the ground. The steam kind of just comes out through kind of vents in the street. And so quite often, if you're driving around in the winter, you'll notice just sort of steam coming out from the ground. And of course, the self-driving car comes along and steam actually shows up really well on LiDAR. You get a whole lot of little points. Looks very similar to like a plant or something. You just get like a whole lot of points kind of popping up in the middle of the road. And of course, a human, you look at this and you're like, yeah, it's steam, I'll just drive through it. But as a self-driving car, that's like a very sensitive, I mean, you have to be very careful to ever override something and say, oh, there's something in front of us, just drive through it. That's like very dangerous, very dangerous thing, right? So we had to put a lot of thought into these things about how do you need to be very confident that there's steam, but there's not like an animal or a small child behind the steam or something. But yeah, it's a very similar thing where if you see this visually, you can just look. If you were just wondering why the car's not going, you have no idea. But if you look at it visually, you can just immediately see, oh yeah, there's some steam there. And that's why, it's like very obvious what the problem is.
Yes. Okay, so I hope that we convince the audience that using visualization tools, especially Foxglove, is a very good idea for debugging your programs. Remember, we started this podcast episode by talking about debugging ROS programs. So I hope that we convince the audience. I just have one final question for you is why the name of Foxglove? Is something I'm missing from English?
No. So Foxglove is a flower actually. So I have this is a Foxglove flower. It's not particularly robotics related, but I really feel that company names, I have a little OCD with company names, and I think that it's very important that if you hear a company name, you should know how to write it down. And if you see a company name written down, you should know how to say it. And sometimes I see a lot of these, a lot of the companies these days have made up names, and I see it written down and I have no idea how to say it out loud. And so, there's some things where I still don't know how to say it correctly. In fact, some people say RQT and some people say RQT. So I don't even know what the correct one there is. So yeah, I am from New Zealand originally, actually, and I was last year when I was kind of formulating the idea for the company, I was driving around New Zealand, the South Island, and there's a lot of wildflowers on the side of the road. And I was looking up what this flower was, and it was Foxglove. And I thought, oh, that's cool. It sounds cool. And it's not. It doesn't have any existing startups with that name, and it's easy to say, and it's easy to write down, and it sounds cool. And it gives us a nice theme for the company. We can have like sort of like, this is why we have this kind of like purpley blues and things through all of our branding. So
okay.
Yeah.
Okay, cool story for the name. Very cool.
Yeah.
Okay, so finally, really final. So where can people find you and your company?
Yeah, definitely. So if you just go to foxglove.dev, DEV, that's our domain. You can just Google Foxglove Studio. We have a lot of community channels. So if you go to our website, you can find links to our GitHub. That's where most of the code lives, and that's where we have any bug reports or feature requests live. There's also a discussion forum in GitHub. And then we have a community Slack channel. So if you go to our website, you can find the link to our Slack there, and you can join Slack and you can just talk to the team and the community in real time. There's several hundred people in there that are just answering questions and helping each other out. And we can always brainstorm ideas there, or if you have an issue you're kind of struggling with, we can help in real time. So yeah, those are the main ways. Come online, find it, you download the app, give it a go. Please send us any feedback. If you want to contribute, we'd love that. If you just want to send us feedback on things that you wish it could do, then we'd love that too. yeah, and feel free to reach out to us.
Yes, so for the audience, I will put a link to all the places, to all the web places that you have mentioned, including the Slack channel, the GitHub, and so on the show notes of this podcast episode. And now you have some homework. This is for the audience, okay? For you that are listening to this podcast, then you have to go and try Foxglove and give them some feedback. As a disclaimer, I'm not paid for that. Just say that this is no any type of benefit or something. I'm just saying that because I think it's a cool tool. And then you can go and help one open source project for robotics and then make better our community. So that's it. Thank you very much, Adrian, for your time here.
Awesome. Thank you, Ricardo.
Okay, thank you. And for the audience there, that's all for today. Remember that you can always learn more about ROS in our ROS Developers Academy that we have at the Construct. You can learn with many different courses. If you're interested in ROS 2, especially, try this ROS 2 Industrial Ready workshop that we are doing online. And in any case, so here we are. Let me know your opinion on the comments and see you the next week with a new lesson from the experts. And until then, keep pushing your ROS learning.